time, we will have two important concepts of definite integrals, and these are the mean value theorem for integrals and the Wallis formula. And in this lesson, you must be able to answer application problems of the mean value theorem and evaluate definite integrals involving products of sine and cosine function using Wallis formula. The mean value theorem for integrals simply states that if the function f is continuous on the closed interval from a to b, then there exists a number c in the closed interval from a to b such that the definite integral of f of x dx from a to b is equal to f at c times b minus a. Or if we will solve for f of c is the reciprocal of b minus a times the integral of f of x dx from a to b. Now, to illustrate the mean value theorem for integrals, we find the mean value of the function f of x equals x squared in the closed interval from 1 to 4 and find a value of c on this interval such that f of c gives this mean value. So the desired mean value can be obtained by the given formula that f at c is equal to the reciprocal of b minus a times the integral of f of x dx from the lower limit a to the upper limit b. So this is equal to 1 over 4 minus a. Okay, so considering the closed interval from 1 to 4, where a is the lower limit 1 and b is the upper limit 4. Okay, then multiply this by the definite integral of f of x dx from 1 to 4. Now, since f of x is equal to x squared, we will evaluate the integral of x squared dx from 1 to 4. Of course, 1 divided by 4 minus 1 is 1/3. The indefinite integral is x cubed over 3 to be evaluated from the lower limit 1 to the upper limit 4. So this will give us 1/3 of 1/3 times the value of x cubed at the upper limit 4 minus the value of x cubed at the lower limit 1. And this will give us f at c is equal to 7. Now, to find a value of z within the closed interval from 1 to 4 such that f of z is equal to c squared, take note that f of x is equal to x squared. So f at x is equal to c is equal to c squared. Then 7 is equal to c squared since f at c is equal to 7 using the formula. And since f of c is equal to c squared, then 7 is equal to c squared. And getting the square root of both sides of the equation will give us c is equal to plus or minus square root of 7. So there are two values of c. One is positive square root of 7 and the other is negative square root of 7. And of course, we are going to take c is equal to positive square root of 7 since it is within the closed interval from 1 to 4. Negative square root of 7 is outside the integral. It's outside the interval rather. Now, for Wallis formula, which is a formula used to evaluate the integral of powers of sine and cosine, then if the integral is in the form sine to the m of x cosine to the n of x dx from 0 to pi over 2, in which m and n are integers greater than or equal to 0, this can be simply evaluated by the formula integral of sine to the m of x cosine to the n of x dx from the lower limit 0 to the upper limit pi over 2 is equal to. Okay, so we start with the factors m minus 1, then subtracting 2 at a time until we reach 2 or 4, Then we multiply it by the factors, starting with n minus 1, subtracting 2 at a time until we reach 2 or 1. And then the denominator is starting with the sum of m and n, so m plus n, going 2 at a time, subtracting 2 at a time until we reach 2 or 1, and then we multiply it by alpha. Okay, now alpha may either be pi over 2 or 1. Alpha is pi over 2 if both m and n are even, and alpha is equal to 1 otherwise. And to illustrate Wallis' formula, if we are going to evaluate sine to the 7th of x, cosine to the 4th of x dx from the lower limit 0 to the upper limit pi over 2, of course, we can use the formula since the given integral is exactly in that form, in the form of the formula. So the integral is, okay, so we start with 7 minus 1, which is 6. Okay, subtracting 2 at a time until we reach 2. So 6 times 4 times 2. Okay, then we multiply it by the factors, no, starting with 4 minus 1, which is 3 times 1, subtracting 2 at a time also. And then the denominator is the sum, the factors starting with the sum of 7 and 4, which is 11. So subtract 2 at a time, 11 times 9 times 7 times 5 times 3 times 1, and then we multiply it by alpha. Since the exponents of sine and cosine are not both even, then alpha is equal to 1. Hence, by Wallis' formula, the integral is equal to 16 divided by 1,155. Okay, now considering the integral of sine to the 6th of x, cosine to the 4th of x dx from the lower limit 0 to the upper limit pi over 2, we can also evaluate this by Wallis' formula. Okay, so we start with 6 minus 1, which is equal to 5, subtracting 2 at a time, so 5 times 3 times 1, and then we multiply it by the factors starting with 4 minus 1, that is 4 times 4 minus 1 rather, which is 3 times 1. And then we divide it by the factors, now starting with the sum of 6 and 4, which is 10 times 8 times 6 times 4 times 2, and we multiply it by alpha. This time, since the exponents m and n are both even, then alpha is pi over 2. Hence, the integral is equal to 3 pi divided by 512. So to summarize, if the function f is continuous in the closed interval from a to b, then there exists a number c on the closed interval from a to b such that the definite integral of f of x dx from a to b is equal to f at x is equal to c times b minus a. And for as long as an integral involving product of powers of sine and cosine function can be fitted to the form integral of sine to the m of x cosine to the n of x dx from 0 to pi over 2, then the definite integral can be neatly evaluated using Wallis' formula.